Alright. Hey everybody. You guys ready for some more live coding? Today I'm going to do some Python. Today, in particular, it's going to be Python web scraping and crawling. And I've got a few things lined up. Basically, I want to build like a cookbook that'll be useful when working with web apps, REST APIs, and will be good for doing bug bounty hunting and stuff like that. So let's see here. I wanted to start off by doing HTTP requests with the built-in libraries, just to have those for references, because you never know when you might be in an environment where you've got Python but you can't install anything. After that, yeah, with the standard library too, you can do parsing and generating URLs, so we can extract the query elements, extract the fragments, extract the domain and the scheme and all that. URL encoding is important, so we'll have a quick example of that. And then we'll talk about the requests library. So we'll do HTTP requests with requests. Well, I guess it's a package technically, but whatever. Library. And we'll talk about how to stream down a large file. And this, when we do requests, we'll cover get and post and query parameters, forms, body data, etc. Hey Mythic. Mythic says, ooh. Mythic, are you... So, do you do any programming? You'll have to refresh my mind. Oh, you said you did this yesterday. Some Python web scraping? Let me guess, you probably used... Did you do some beautifulsoup? Or what did you use? How to stream down a large file, using regular expressions to match script elements. So we're going to do kind of a variety. All of these things are going to be useful. Regular expressions, streaming down files. Yeah, we want to say crawling a domain. And we'll say with the thread pool. Proxying requests. Like looking for URLs that have query parameters. This is going to be kind of like, that'll be more like a bug bounty kind of task. So, what else? Beautifulsoup scraping basically. And then maybe I'll look at Scrapey a little bit, but I'm going to focus on building our own stuff. So this is more or less the agenda, is to build a cookbook of examples that do these things. And actually, what would be cool, we'll try and do a real simple GUI application where we can just post in some data and have it post to an endpoint. It'll be useful for doing REST API testing and stuff like that. So that's the agenda. I'm gonna go ahead and open PyCharm. Give it a minute to load up. It's a little slow to start up, but it's worth the wait. Alright, it looks like I still have the port scan collection project open, so I'm going to close that from last time. And yeah, I want to open the cookbook. I'm just going to dump it all in there in the Python section. So yeah, I have some other examples I might reference from too, but I'm going to make a new folder specifically called web scraping. And I'm just going to put our examples for today in there. Now, just to check on things, I'm going to make sure my repository is clean and is up to date. Okay. Everything looks good. So, web scraping. I'm gonna call this one URL live examples.py. Now, one thing to keep in mind, if you're writing your own, don't name your files the same thing as the libraries, because it will confuse your import statements. That's why you see me suffix so many of my directories with _ examples, because I've been burned by that a lot. I see that a lot when people are making the Discord examples. They'll make a bot called discord.py as their example, and it screws with the library called discord.py. Mythic says, yep, he used request, beautifulsoup, and wget. Yeah, it's a good combo. You might want to add in downloading files. GitHub repo with git.exe. I'm not sure what you mean. I do have on the agenda how to stream down a large file. That's also good for a small file. So we'll cover file downloading. So HTTP get and post requests with standard library. Now, in Python 2 and Python 3, the libraries are different. So I'm going to start with Python 3. We'll just check out URLlib. And they separate it into a couple ones. Now, parse isn't what we want because we're not parsing URLs yet. We want the request. And they have one called URL open. Open the URL. That looks pretty much like what we want. Let's see what else they have. They have one called install opener, build opener, path name to URL, URL to path name, get proxies, request. It looks like you can pre-build your request. Actually, that might be a nice way to do it. And then what, you request.get or what? Let's try it out. So let's create one of these. And we'll say request equals that. And it's all red squiggly because we need to import it. So we alt enter import URLlib. But that's not quite enough. So let's say, I wonder if we do alt enter what it'll do here. Yeah, no, so we'll do, can we do it like that? Yeah. So now we have the full import that matches it. And from there, we can use the help built into the editor. So we see over here on the right where it says request. That lets us know that the function or the property is specific to the request class. And then you start to see object. And these are things that are properties of all objects. So these are nothing special to a request object. So it helps to pay attention to what's over here on the right side. So what do we see? Data, add header, full URL. Yeah, this makes sense. You're basically creating the thing, but I want to see how do you do it. Do they have another function called do request or something? Hold on, let's see what the docs say. Hold on, I lost my spot here. Request. There we go. Let's see. Do they have an example? Request.method. So you set the method. Yeah, that's fine. opener. Let's try this Python 3 URL live request example. Now the whole reason people use the requests package more often is because it's, oops, that's not the right one. It really is a hassle to use the built-in Python library. Yeah, I know, and I'm totally going to do requests, but I want these examples just in case the requests library is not available. Okay, so URL open is the way to do it. And you either pass it the straight URL or you pass it your request object. So, yeah, let's say request devdungeon.com. And we'll print the response dot, well, let's just see what happens when we print that. Oh, well, we gotta do read. So we'll do print response.read. And we already have that imported. So you can say open URL with string or pre-build the request in case you need to make modifications to it dynamically, which can be really nice. So then we will actually do url_live.request.urlopen and then the request. Now what is it complaining about here? I guess it needs a URL, at least in the constructor. Okay. Okay, and I'll just print out a separator. So if we run it, this should work and it should print out the response. Excellent. Cool. And so let's say, on the request, just to show we can do it, we'll say add header, and then the key and the value. So we'll say something like user agent is not Firefox. Oh wait, it should just be a comma. Okay. Cool, so that's how you do it with the standard library. Now in Python 2 the import is slightly different. And basically the difference is that in Python 3 they separated the URL live into like the request and the parse sub packages. URL open. Yeah, so in Python 2 it's just like that. So what you can do to make it work both ways, and I'm pretty sure this will work just fine, is you can say try, and like if this happens to be Python 2, then it'll have an exception, and then it'll fall back to this, and it'll import URL live 2. And we can try something like this. From URL live 2 import request. And then I think we can do the same thing like that. And then we'll have something a little more consistent that we can use. Okay. So now this should be kind of compatible with Python 2 and Python 3. So just to try it out, I should be able to swap my interpreter to Python 2 real quick. Let's see, system interpreter, yeah, Python 2. Okay. Now it's going to index down at the bottom. You'll see it's indexing real quick. Processing all the libraries. I just want to make sure that this will still open with Python 2. And then we'll check out, we'll start moving down the examples. So this one is almost done. Parsing and generating URLs and URL encoding, those should be real quick, but those are going to be important later on. So we're going to build up some building blocks. Okay, so it should be done indexing, so I should be able to run it. No module named oh, I'm missing an L. It should be URLLib2. So now if I run it, cannot import request. Okay. Oh. Wait a second. There's no request, so what I really need is URL open, and what I need to do up here is say from URL lib.request import URL open, and then just we can do it like this. Oh wait, we need the request. So where is the request class in Python 2? Let's see. URL lib2.request. Okay, no problem. We'll do an explicit import there too. So we'll just duplicate that line and say import request. Oh wait, we can just do a comma. We should just be able to do like this. Import, and we'll also import request here. And then down here we'll just call it directly. There, so this should work now with Python 2. Cool. Now if we switch back to Python 3, it should also be compatible. Even though they have the different imports, it should... Okay, what did I mess up here? Line 17, request. Oh, I had to call it that where I shouldn't have. Okay, so that works, and I'm going to make a little comment here that says for Python 2 and for Python 3. So this probably isn't the way I would do it normally. I'd probably use the requests library, but it's good to have this again in case you're in an environment maybe where you have Python but you can't install anything. You can't even do a virtual environment. Maybe you can get away with just using the standard library. Or if you just want to avoid any dependencies. So we've got the URL lib examples. We can cross that one off the list. Parsing and generating URLs. So in this one I'm going to look for Python 3. It's called URLParse, I think. URLlib.parse. And then there should be a function, yeah, called URLParse. So I'm actually going to make a new one called URLParsing.py. And in this one, I'm only going to do... Mythic says most of the time you can do -- user. Yeah, and you're referring to like installing dependencies and stuff. And you're right, but I'm thinking in the case where like, oh, let's say you're injecting code. Like the other day we did a Drupal exploit, and it's a little more difficult to like do a pip install on requests as opposed to just jumping in some Python code right there. Anyway, so from URLlib.parse, import URLParse, and we'll try that. Otherwise, it's just going to be from URLlib2 import URLParse. I believe that's all we have to do. So here we'll just call URLParse, and then we can give it a URL. So let's give it like a fully featured one. Q equals 5 and X equals that, and we'll give it a fragment called test fragment. So that's a nice fully featured URL. And I'll give it a little space. So this should give us the URL broken down into little pieces. Yeah, so now we can say, let me duplicate this a few times, and you can say print.scheme, net location, the path, the parameters, and you've got what else? The query, which is all the, then we've got the fragment. Yeah, so if we run it again, we'll see we got all the little pieces. So URL parsing makes it really easy to just dump in a URL and see like, oh, does it have query parameters at all? If you're doing bug bounty hunting or something like that, it's helpful to just look for URLs that have query strings in them because they're usually right for the picking. Yeah, dude, that's effed up. Says I usually work with requests. Yep, that's what I would recommend too. So I'm gonna cover that in just a second. So URL parsing. Now the other way, I want to do it the other way. What if I want to create the URL? How do I create one then? What is that object called? No, let's go back up to the check and top. URL parse. Well, what does it return? It returns a parse result. So can I go the other way around? Let's see. Python 3 create URL parse. URL unparse, that's the one. Okay, unparse. Let me go back to the right one. So we'll go into URL live.parse and we'll look for unparse. There we go. Okay, construct a URL from a tuple as returned by URLParse. Okay, so we can create a new one and say new URL equals URL, wait, URL unparse or just unparse? Yeah, URL unparse. And then we pass it a tuple with all the things inside of it. So we'll go ahead and add the imports. Same thing here. And wait, how do we pass it in? The parts argument can be any 6-item iterable. Now wait a second. What was I guess you have to do it in the exact order. I see. Yeah, you pass it none. So that would be. We'll try it out. So we're gonna pass it HTTPS as the scheme. So, dude, that's effed up. Ask what's a tuple. A tuple is very similar to a list, if you're familiar with the list, except it has a couple special properties. It's immutable, mostly. That's really the special property. Like, you can't append to it, you can't change the values, you can't change it once it's created. And then the net location, we'll do devdungeon.com. The path is going to be /. We'll do /archive. And parameters, we don't have any parameters. And now I'm not positive the difference between parameters and query. Now is that, what's that? Okay. And the fragment. And the fragment would be what we just said, so it would be a test fragment. Okay, so if we pass all that, then we can say print new URL, and then what does it return? Let's just see what happens when we print it. Okay, so we're gonna run it again. And then at the bottom, we see here, this is the URL it constructed, and we see it does build it properly with the query and the fragment and all that good stuff. So this is how you create a URL. And I'm gonna break this out a little bit and comment it slightly. So break there, there, there. So here we'll say we got the scheme, net location, path, params, query, and we'll look at how how to create these query parameters out of a dictionary, you can do that with one of the helper functions that they have. So I'll show you how to do that in a little bit. Okay, so now we've got parse a URL and create a URL. Now, just to make sure it works with Python 2, I'm just going to switch my interpreter real quick. And, ooh, URLParse is not callable? Let me try, let me just give it a run. Cannot impart URLParse. Does that even exist in Python 2? Let's see, URLUnparse. Oh, it's in a totally different package called URLParse. Okay, so I guess it's from URL. What was it? URLParse. URLParse. Okay, that looked better. Now it runs. Cool. So now we've got Python 2 and Python 3, so we'll do Py2 and Py3 comments. Cool, so now we've got parsing URL done. We can knock out that one. So URL encoding is another one of those important prerequisites to kind of knock out. URL live, URL encode. Let's see. There we go. URL live, parse, URL encode. Okay, oops. I opened like a whole folder by accident, I guess. Let me close all these. Okay, let me open a new file. This one's going to be called URL encode. ing.py. Okay, yeah, so we need Python 3 imports from url_live.parse import URL encode. And in Python 2, I guess it's going to be from URLParse import URL encode. Okay, and then we're just going to call URL encode directly. And I guess we pass it in the dictionary, right? The dictionary of stuff. Query. Convert a mapping object or a sequence of two-element tuples, which may contain string or bytes objects. Yeah, so it should be a dictionary. So this would be like Q equals 15 and action equals something. And then if we print that, well, let's just say query string equals that, and then we'll print the query string. Okay, so we'll run it. Cannot import URL encode. Okay, typo? Was that it? No, I'm still in Python 2. So let's see, URL encode. What is the import for Python 2? URL lib. Okay, so it's just from URL lib, like that. There. That's better. So now you can see it prints out, you know, Q equals 15 and action equals something. So that's how you get, like in this other one where I just wrote this, you could say use URL encode. And this is an example of that. Okay, so that's all we need as an example there. Now we know how to make the query strings. That'll be useful later. So what else is on our list? Okay, now we're using the requests library. For this, I don't even really need the documentation. It's so simple that you don't really have to think much about it. Dude, that's effed up says, what would we do without Google? I would use the official documentation, and that's it. Like the official docs for each plugin or module and the official Python docs are actually really awesome. If you like the official Python documentation is very underrated. It's like it's a book. They've got a whole book basically. So when people say what should I do to learn Python, I say go look at the real docs that like come installed with Python and that whole document. Anyway, import requests. Request.get is pretty much all there is to it. I'm going to switch my interpreter back to Python 3. Python 3. And the good thing about requests is it works for both, pretty much the same. And so I'm going to do https devdungeon.com/archive, why not? Okay. And so you get a response, and in the response you get the text, the status code, and what else? The cookies, the headers. And so you can say print, and we'll just print out each of these. So I'll run this. Let's see. So that's the whole body, whole HTML body, and that's takes up a lot of space. So I'm going to comment that one out. Yeah, 200 status code. Okay, and then this is all of the headers that were printed out, that came in the response. Okay. Cool, that's how you do a get. And we'll just leave it like that. And we'll do a request.post as well. And actually for a post, I'm going to use HTTP bin. It's a nice little site for doing debugging. And so they have request inspection. Let's see. I want to do a post test. Okay, so they've got one. Here we go. /anything. We'll post to httpbin.org/anything. And it should send it back. And so let's just print the response.txt on that one. And I'm going to comment out all this for now. And let's run it. And it just echoes back everything we sent it. So it tells us there were no args, there was no data, no files, no form. There were some headers. The method was post, and it sent an IP address. So we've got... where are we? We need to send it some stuff. So we can say files equals... and then file, and then you'd have to actually send it the bytes. That's actually going to be ASCII. Yeah. So the file contents. Now I'm not sure if it has to be a bytes object. Let's try it without it. Yeah, it works without it. Okay, so you send files that way. You do data like this. And I'm not sure if the data, this is going to be the post body data. Okay, so this one I think does have to be bytes. No, data must not be a string. Okay. Do I get the same thing if I do this? Yeah. What if I send it, how do I do it? Like this? 0xff. That's how you send not string data, right? Data must not be a string. Wait, is it complaining about the file? Or is it complaining about this data? It's complaining about the data, right? Yeah. Data, not a string. So I thought it could be a string. So hold on a second. Requests library. Data must not be string. Oh, I think I just need to encode it. Body. So this is gonna be the post body contents, and then I gotta do encode, and we'll do UTF-8. No. It's not decode. Hold on, let me see what they say here. Oh, do they actually expect it to be an object? No, I don't think that's right. An object? Like, let's give it a dictionary. Oh yeah, it does. It does like that better. Let's see, requests. Request Python data example. Now there's a couple ways to send data. Yeah, so data equals key value. Now okay. So we're gonna say, yeah, key value. And where does that show up here? In the response, it shows up under form. Okay, that's where I was getting a little mixed up. So the data is not the body, it's the form field. Form field name. And yeah, the form value we want to send. So that's where I got a little confused. Data is actually the form value if you have some. And data is still empty, so hang on a second, let's see. Let's search for data. Passing parameters in the URL. No, okay, I already know about the parameters. The parameters are the query parameters. So yeah, you can say that's a dictionary too. So you can, that's where you would say like Q is 5 and action is delete. Now if we run that, we should see args. I guess that's what they're calling the query arguments. Query args. Okay, so it's just confirming the stuff that we're sending it. And what's the last thing we need to do? The data. No, wait, we did the data. So what about... Can I just pass raw data in the body if I want to? Or is that what it does with the data? I think that's enough for now. So we'll cross any of those bridges if all of that fails. But those should cover some basics of using the requests. So we got a post here. We got a get up here. Okay, so those examples are good. We can cross that off the list. So yeah, we did all this. Query parameters, forms, get and post. Yeah, so streaming down a large file. And I'm pretty sure they have an example here in the official requests. Yeah, so beloved features. Multi-file uploads and streaming downloads. So advanced usage, yeah, streaming uploads, streaming requests, and let's see, it looks like they have several. Okay, so let's take a look. Streaming uploads, data equals F. Okay. So actually, I do want to put that example in here for the data. So, or stream data in upload. So, with yeah, we'll call it large file.txt. Oops. Okay, so we'll try http bin. .org/anything. I don't know if it'll accept this streamed data or whatever, but we'll try it out, and we'll not make it large. File contents. Okay, so let's see how that works. Now, we didn't print the response or anything. That's why. Print response text. okay, we can run it, and at the bottom we'll see data, and it did send the data of the file. And I guess it will automatically stream it. So that's kind of a nice thing. Chunk encoded request, post multi-part, multi-encoded files. Okay, so files, yeah, let's say can pass a list of files and actually pass them in a tuple. I'm gonna toss this one in there. Well, yeah, I'm just gonna leave that in as a comment. Okay, so that's enough there. We did how to, well, that was how to stream it up, so where's the down? Yeah, so that's how you stream it by line. I think there's another one called iter chunks. So iter lines is okay for like HTML content. Oh, you just turn on stream equals true on the download, that's all. Okay, so let's make a note here on the get. We can say stream equals true, and I don't think that should have any effect if we just do a regular get. No. Oh, I shouldn't capitalize it? Yeah. Okay, so that's a good example to keep in there. Okay, so we're done with a lot of these little prerequisites. And then use... Well... I'm just going to leave that as a comment too, just as a reference for later if we ever need it. Okay, so now that we have done kind of all the prerequisites of learning how to manipulate URLs and do downloads and connect and do posts and get, now we can actually start parsing. And so there is a beautifulsoup library, and that's what I would recommend, but it's really, really important to understand these fundamentals too. And if people just want to go to the beautifulsoup tutorial and do that, then they could always do that. But what I'm doing here is trying to build up the whole thing. So regular expressions, again, not the ideal way to do it, but it's important to have in your arsenal, and it can be useful in many situations. So we're going to cover that before we go and use something like beautifulsoup that will do a lot of this for us. So we'll look up Python regex, clean up some of these tabs. Okay, so we're in the official docs. Let's look for a quick example. Here we go. re.search. And then we give it the regular expression and then the thing to search. Okay, so let's try regex example.py. And let's just try something like, so we'll do a needle in the haystack kind of thing. So we'll say the haystack is a bunch of text, and in the middle we'll put a script tag that says JavaScript here, and then close the script, and then some more junk. And then the needle is going to be like our search term. And in this case, like it's going to be, I guess we can just try and look for a string like that, a straight string. And so it's what? re.search needle haystack. We'll do import re. And what do I get out of that? What do I get back? Oh, it returns the compiled. Okay. and then you use m.group or response.group. We'll say I don't even know what to name this because I'm not sure. So x.group, and they called 0. So we're gonna say this, and we're gonna print the type of y, and we're also gonna print the type of x to see exactly what the type is, and then print y. So let's see how that works. Okay, so the x that we get back is a regex match object, and what we get back and y is the actual match. Okay, so we found the match, but really what we want is like everything between the open and the close. So we want everything, I guess, we're gonna want the, like, define everything up to the slash script like that. Now, I forget, we're gonna have to do, they have a reference up top of what the regex characters are. Dot is the default, matches any character except a new line. Okay, so I think we want dot plus. Causes the resulting regex to match 0 or more repetitions of the preceding. No, we want dot star, I think. Okay, so we want script with anything to a closed script. And then let's see what we get there. There, now we get the whole thing. We get the whole script tag. But I think they said it doesn't work on new lines. So what happens if we inject a new line there? Yeah, it doesn't work. Okay, so not the plus. Causing the resulting RE to match 1 or more repetitions. Let's see. I basically want the star, but with new lines. Now if we run it again, because there's going to be new lines in there, most likely. So let's see. Dot. Okay, so maybe it's not the dot I want. It's not the want. I want the dot. Well, I guess maybe I could say dot or new line. Right? I could say dot or new line. Now let's try that. Yeah, perfect. That works. And so we can probably, well, we should be able to inject as many as we want. Boom. Now we can identify any script, and we can even say like script source equals blah blah blah. Then it should still pick up that. Yeah, so like even if there's no body and it was just script source equals that. Oh, actually, you know what? If it was just like this where they did script source equals that and that was it and it closed it. Is it a single tag? Is script a single tag? Let me go check. So if you go view source and we do script source equals, oh no, there's still a closing script tag there. Okay, so we're good. Cool, so that's how you pick out script tags, and you can use that to just see, let's say you're crawling a site, you want to pull out all the script tags, figure out all the references and all that. Okay, so I guess if we do group 1 it'll say failed. Yeah. Okay, so this is going to be regex match, and here we're going to say regex match dot group, and we're going to say full text match. We'll say text matching text, and then we'll print out the matching text. Okay, cool. So there's a good regular expression example. Now, what else is on the list here? Crawling a domain with a thread pool. Okay, I'm actually going to push that till after the Beautiful Soup one when we're actually extracting links. And so in the regex one, you could, you know, do the same thing for things like image tags, and you could look for, or I guess that's not where you do it, it would be here. You could say, like, I am interested in image tags that do like that. Or A tags. And I guess A tags don't have, they shouldn't have new lines in there. So those are some other examples. But that's not the ideal way to do it. It's better to use something like beautifulsoup. And I'm going to defer the proxying request as well. Okay, and that is going to go with the crawling. It's going to be part of the crawling. And so that's kind of how we're going to look at the rest of this. Sorry, that keeps popping up. Okay, so now that we've looked at requests and we've looked at the core libraries and we've looked at the regular expressions and we've gotten all of those basics out of the way, let's start looking at a nice library, and it's called beautifulsoup. And this library makes it much easier, and I think, yeah, I have an example right here. So what I'm gonna do is first pull a request. So we're gonna say response equals requests.get dev dungeon, and then do import requests, and then response.text is gonna have the body of the contents. So in the beautifulsoup example, yeah, you just create a new beautifulsoup object and you pass it the body of the content. So I'm going to do Alt-Enter. Okay, hold on. So beautifulsoup Python. The package name isn't just called beautifulsoup. I think it's called BS4. So let's go to the installation. Oh, if you're we'll go ahead and use pip. Oh, okay, so it's beautifulsoup 4 fully written out. So hold on, let me set up. I guess this should be fine. Pip install beautifulsoup 4. Okay, that works. So now I can say from BS4 import beautifulsoup. Is that right? Am I using the right interpreter? No, I think I was probably using the Python 2 one. Okay, there we go. Now I have it installed for Python 3, and we're back to our beautifulsoup object. And now we can say, now we've got the whole beautifulsoup object to do all kinds of cool stuff with. And once you get that soup.prettify, I guess that's the one you use to print out just a nice version of the HTML. Okay, so I actually made a request to Dev Dungeon here and printed out the prettified. So I'm actually curious, if I print out the text instead, is it going to look a little bit different? Yeah, it does. It looks like it actually does some indentation and stuff, so that's pretty nice. Soup.title, yeah, okay. So you can grab individual elements. So let's try, let's say if you're crawling a site, you might be interested in the title, right? So we'll start by printing the title and actually commenting that out. Oh. What is it complaining about? User warning, no parser was explicitly specified, so I'm using the HTML parser. Okay, I think I need to say parser equals html.parser, and that'll make it happy. Maybe not. Let's see here. I thought that would do it. Let's see if I'm using if I'm setting it here. No? Well, whatever. It's choosing a safe default, so that's fine. So we've got the title, it's printing out the title, and in our other example we have, oh yeah, so in the title, when you do the title, it's going to print out the whole title with the actual HTML tag. So I believe if you do title.name is when you actually get the text alone. No, wait, that's the wrong one. String. There we go. So if you just print the title, you'll get the entire tag with all the attributes and everything that go along with it. But you can just print the string. So like, let's say you're storing all this in a database when you're crawling. You'll probably want the title. What else can you get? So yeah, you can use the find all to find all of the elements, and I think you pass it in kind of like jQuery style selectors, CSS selectors. In this case, we'll just say look for all the, well, let's go actually look at the page. So where's all the links? Are these all the links? Okay, so there's no class. So let's see, we want all the A's inside of a T-body. So I think we can do something like that. We'll see if that works. For A in find all A's, print A.string. We'll try that out, see how that works. Yeah, it didn't like, no, that's all wrong there with the CSS selectors. But so if you just do A, you'll get all the links. And if you print A.string, you can print A.href, and you should get, now maybe that's incorrect. Hold on, let me go back to the other example I had. .get, okay, so you have to do a .get on the attribute. It's a .get href. Okay. And then print a dot, where was it, string? So that's how you get the text. So now you can see the title of every URL and the actual URL that goes along with it. Okay, so that's how you find all the links, and like, let's repeat it for all the images. So we'll say find all of the images for image in soup find all image, print image dot get source. So we'll print all the image sources. And so we can see it looks like there's not a whole lot of images, but there is a couple, and so you can see, yeah, there's a JPEG right there, Discord join logo.png. And so if they have alt texts, you can look up the alt. And so, yeah, you can see none and none, so those images don't have any alt text. Wait, that one does. That one should. It says home. Oh yeah, it does right there. Boom, home. That's the alt text, and these two don't. Okay, so that's how you can find all the links and find all the images. And I wonder, can we do the same thing with the scripts? Can we say find all script, kind of like we did with the other one? And you sure can. And it looks like it. Let's see if you can get the ones that have the text in the body. So what if we do script.string and script.source? So let's check that out. See, a human says, can you make money on YouTube yet? And no, I have not been monetized by YouTube yet. Okay, cool. So look, now we can see the inline JavaScript and the ones that have sources. So that's awesome. We can find all the scripts, find all the images, and find all the links. And look how easy that was. Look how few lines of code that took with Beautiful Soup. That's why this library is really awesome. Okay, so now, I mean, that's right. There's Beautiful Soup. I mean, it's got some more advanced features, so like let's check it out. But that's the gist of it. So this is their quick start page. Oh, let me make it bigger. This is the quick start page on their official documentation. And it's very similar to what I had. Okay. So I wonder if you just do soup.p, does it just give you the first one? Okay, so you can find by ID. You can find them by tag. Let's see. Making the soup. Yeah, you can use a file or you can give it raw HTML. I want to see a couple more of those search examples. Oh, there's a replace with. That's interesting. Okay, so nothing we haven't seen yet. Oh yeah, you can get the children. So that can be important if you just want to grab a div and then grab all the children. So it makes it really easy to interact with the DOM. But for now, I think that's good. So let's take a look at some of these other examples and see how far we get. So let's do this one first, where we look at URLs that have query parameters. And so let's go back into here and say, in the where we're looking for, well, hold on. I'm gonna go back and close these. I'm gonna create a new one, and this one's gonna be called look for query strings .py. And basically this one we'll start with this one as a base, delete this, and actually I don't even think we need requests. I think we can just pass it a URL, and I think it will know what to do with it. No, I guess not. That's fine. We'll just use request to get the body, and let's take a look here. Okay, so what we're going to do is for every link we're going to use that URL parsing that we learned earlier. A dot get href, and we're going to import. Okay, so URL is all that, so we can say URL dot what was it? Let's pull open the example. URL parsing. You want query dot query. It'll say if URL dot query print query string found in URL, and then let's print out the URL dot, well, I guess in that case let's just print out, yeah, we'll just print out the URL object. That should be fine. So let's see if there are any URLs with query strings. Wait, we don't want to print all of them, so let's comment out the print line. And okay, look, it did find a couple. It found 2, and here's the query. Order equals title, sort equals ascending. So this can be really useful if you're doing, like I mentioned earlier, bug bounty hunting, penetration testing, stuff like that. You should pay special attention to URLs that have query strings, because those are prime targets for IDORs, indirect object references. They're prime targets for SQL injection, other kinds of injection. They're just, you really want to pay attention to those and mess with them. So that will help you find URLs with query strings. Let's also look for, so let's do this actually. What I want to do is also check, and I want to see if the URL is a relative URL to the same site, or if it goes off-site. So what I'm going to do here is say starting URL equals that, but actually I want to, well, we'll do like this. So if there's a query, we'll just go ahead and print it out. Also, we want to see if it's relative, right? Check if URL goes offsite. Now there's two ways we need to check this, right? Well, let's say this. Check if URL stays within domain. That means one, the URL is relative, begins with a slash. So then you know it stays on the site, it's only relative. And two, if the URL has the same net location. And that in the URL is basically the domain name. So we'll say if it's a relative URL or the URL has the same domain name, we will consider it staying within the same domain. So we'll say we want the href, and we've already got that parsed out. So we'll say if url.netlook equals none, or we'll say is none, or url.netlook equals, and I wanted to say the base URL, but in this case we'll just say base domain. Okay, so if it's one of those, we'll say print on-site URL detected and print out the URL. And we'll do the same thing up here. Okay, so let's try this out. Not all arguments converted during string formatting. Hold on a second. URLParse. Having a moment here. What is it complaining about? What line? Yeah, right here. I guess it doesn't like. It doesn't like me trying to parse it as a string. What's the debug formatting? Python print format debug? I'm going to just defer. I mean, this shouldn't work well. Maybe if I do a stir, maybe that'll kind of force it. Yeah, that worked better. Okay, yeah, query string found in URL, boom, boom. But what about if the net location, no on-site URLs detected? Is that what it's saying? Surely there's, I know for sure there are, so let's do this. Let's say print url.netlocation, and let's see, make sure it matches what I expect. Oh, so maybe it's not none, maybe it's an empty string, so maybe it's equals blank string, blank blank. Okay, yeah, that seemed to do it. Okay, perfect. On-site, wait. Yeah, there we go. Otherwise, so why is it printing that one? Why is it printing these? Let's see, why? Oh, because I told it to print it out. Derp, on line 17, let's rerun it again. Great, now it finds the on-site URLs, and it finds the URLs with query strings. Both very useful, especially if you're doing bug bounty hunting. You need to make sure you stay within scope. It's very important you stay in scope, Otherwise, you might start testing properties that you have no permission to, and you could end up breaking the law. So you got to be real careful there. Pay very close attention to the scope on any bug bounty program. Okay, excellent. So this is going to be important when we're doing our crawling, because if we want to crawl and stay within a domain, we'll want to find all the ones that stay within the site. So this is not just looking for query strings, it's looking for... okay, we'll call this one examining A tags. We'll say anchor tags. Okay, so that's how you examine the links. Okay, and we also looked at finding URLs that stay within the same domain. And we can get the domain by parsing the URL. So we can say starting URL equals that, and then we can parse that one too. So we can say parse starting URL equals URLParse. And then, so base domain can be, we don't even have to say it, we can just do parse starting URL.netloc. That way, no matter what the starting URL is, you know, we can put this whole thing in a function and feed it in whatever we want as a starting location. And it'll automatically detect the base URL. Oh wait, I gotta give it the starting URL there. So there we go. That's going to be useful. You know, I might start doing some bug bounty hunting type stuff, because that's really one of my specialties. Not bug bounty hunting, but web application security. Web application security is probably my strongest area. So I've always wanted to do the bug bounty hunting a little more rigorously. So I might start getting into it a little more. I do application security for a day job, but not bug bounty kind of stuff. Okay, so we got a couple things left on the to-do list. We've got crawling a domain with a thread pool, and you know what? Since, to be thorough, I am going to mention Scrapey. I didn't want to actually use it because I wanted to build my own and show the process of using a thread pool to crawl and get all the sites and do all that. But Scrapey really is a good framework if you really have to do large things, but I like building stuff from scratch. So I'm going to take a real quick break and, well, yeah, I'm going to take a real quick break. I'm going to grab some water. And I'm going to be back in like 5 minutes or less. If you guys have been sitting around for a while too, go grab yourself some water, give your back a stretch, and I'll be right back. I'm going to put on some music and be right back. Alright, I'm back. Let's get back to it. So there's a couple things left on our to-do list. Crawling a domain with a thread pool. Okay, so let's call this one domain crawler. And so what this one is going to do is, given a domain name or starting URL. Oh, I left off the .py extension. Given a domain name or starting URL, we're going to say parse the starting page looking for A tags. Hello, Mythic. Mythic says hello. So hello. Let's see. So we're going to parse the starting page looking for A tags. And then we're going to check the A tag to see, well, we'll just say check the link to see if it stays on site. And then if it stays on site, then what do we want to do? Then we want to follow the link. Follow the link and repeat. So it'll be kind of a recursive algorithm. Okay. And that's it. Well, there's more than that. We actually want to store. We want to output all the data found to a spreadsheet. And we can use, I believe, OpenPyXL is a good one. You can also use the CSV, and maybe that'd be better. I'd kind of rather do the Excel example because you can put images in Excel documents, and that can be really handy, especially if you're throwing in screenshots for sites. You can't do it if you have a ton though, because the whole workbook just starts breaking, but we'll do it all out to a CSV for now. I've got examples of doing spreadsheet stuff. So yeah, I do, if you have any interest in doing spreadsheets with Python, I do have a whole tutorial on working with spreadsheets in Python that covers CSV and Excel. So you can use that as a reference if you want to do that stuff. But we'll go with CSV since it's easier, but I do want to dump it all out to a spreadsheet because I want something usable. I don't want just a big console dump. I'd like to open it up and look and start looking for any interesting URLs. And so what do we want to track? We want to track the title. So we want to track the title, the URL. Does it have query parameters? That's going to be interesting. Any scripts? Any scripts found that it links to could be interesting. And we'll just start with that. That should be fine. Okay. So this is our pseudocode for our goal, for this little domain crawler application. And so basically we can give it a main and say like crawler equals, we'll call it domain crawler. And then you give it a domain or a URL. We'll start with the URL. Okay, and then we can do Alt-Enter, create class. It will help us get started. We don't need to inherit from anything. And we'll start with an initialization function. And so what do we need to store? We need to store the starting URL. And I guess we can put that here. Starting URL equals self.starting URL equals starting URL. Okay, and then we'll want to parse it. So we want to do URLParse starting URL. and we can alt enter to import. And let's store that too. We'll just call it parsed starting URL. And what else do we need to store? Given a domain name or starting URL, we can delete that now. Okay, so we'll put all this kind of inside the class. And so down here we'll say if name equals main. And this is basically going to be how we want to use it. Crawler dot start. Yeah, just like that. Okay, so parse starting page. It's going to be kind of recursive, so we want a function called, well, let's start with the little pieces that we need. So def does URL stay on site, and we'll pass it in the href. And now we can use the example. We're examining anchor tags, and we can use this example as a reference. Does URL stay on site? And in this case, it's basically checking this if condition. We're gonna have to parse the URL. So URL equals URLParse, the href. Okay, then we can check the net location, see if it's either empty or if it matches the self.parse starting URL net location. And then it does, so we can return true. Okay, so we've got that function down. And then we have another one saying, okay, so we can delete this little line of pseudocode. If it stays on site, follow the link and repeat. It's looking for A tags, and then we say for each A, if it's on site, follow the link. So we'll call this one process page, and then we give it the href that we want to send it to. Okay. Then we'll parse the href again. So we'll say URL equals URLParse href, and then we'll say if URL netloc is none. Let's see, or is it equals this? Yeah, actually, it is going to be this one. Process page. Well, how do we want to do this? This is where we're going to look for the A tags. So we're going to have to do a get the href, beautifulsoupify the contents, and then extract all links. And then we can do the looking for the links like that. Okay, so that's kind of our pseudocode for process page, and then follow the link, and then we're going to say basically what that means is process page, the new link, the new URL. So it's basically a recursive algorithm that will keep calling process page until it runs out of links to process. Okay. So get the href, we're going to have to do a requests.get. Now the href, though, might only be a relative URL. That's why we need to parse it and check to see if it's only a relative URL. And then we can say if you are, oh wait, I did that at the bottom already. Well, I guess, yeah, I need to do this up here. then the URL net location should be set to the starting URL net location, but we should also set the scheme. What is it? Schema? URL parsing, it's called scheme. Can we set it this way? I wonder if we can. Self.parsed starting URL dot scheme. That way, if it's only a relative URL, it's only the slash, then we'll go ahead and set it explicitly to be the site that we're working on. And then we can say, okay, we can't pass it the URL, can we? Does requests know how to handle that type of object? I guess we'll find out. And so we'll have a function called start, and then we'll start by calling self.processPage on the starting URL. Let's see if it does handle the parsed URL. Okay, so this should just call one request and then end, basically. So we'll just see if it works. We'll go ahead and run it. Yeah, parse result has no attribute decode. Okay, I think it's complaining about me passing the URL into here. Starting URL. Okay, I think this one will work better. Okay, yes, now we got a different one. Invalid URL. We've got HTTPS, dev dungeon. Oh, there's no path. No schema supplied. I see it. No schema. Is it schema instead of scheme? Or wait a second. What line was it complaining about? Line 42? No, line 33, line 18. Okay, so it doesn't like me trying to set the URL like that. Like, I can try schema, but I don't think that's the problem. I think the problem is that I can't update this object like that. So let's see, URL parse Python 3. So let's see if they have an example of updating one after you. Yes, it's definitely called scheme, but it's basically saying I didn't provide it. But if I look right there, you see it, right? No schema supplied. Perhaps you meant okay, let's see. And I guess we can try and do it kind of manually. So instead of this, we'll construct the URL like this. We'll say if it doesn't exist, then the target URL is, well, I guess we could just update the href itself. So we'll say href equals href, but prefixed with the schema, the scheme plus the net location plus the href. Print the href and try and get it. Okay, so let's run that and see how that works. Yeah, that's working better. Good. But now we need it to actually keep running, so we'll say print response. No, we want to soupify the response. Response.text. And we want to beautifulsoup the response.text. Go ahead and import. And we'll say the soup equals that. And then we can do the soup.findAll and find all the A tags. And then we can say for A in findAll. A.get the href. And pass that to the does URL stay on site. Self.does URL stay on site. And then we can say if self.url stay on site, then process page of a.get href. Boom. Recurses on itself. Okay. Now, every time it gets one, we're gonna say processing href. So kind of a debug to see how it's working. Okay, so it needs me to add the // in between this one and this one. Oh, it needs the ://. There we go. Ooh, it's it looks like it's looping over on the same page. That's not good. So what we need to do is check and store all the visited URLs. So we'll say self.visited URLs equals a list, an empty list. And then every time we process a page, we will store visited URLs dot. Is that what we'll do? Yeah, so after we get the href, one thing that concerns me is the fragments. You don't want it to fall into like a deep recursive loop over fragments on the same page. So I might say, and same with the query parameters, but they can be legit, so I'm gonna just ignore that fact for right now, and I'm just gonna say it's append, right? Self.visitedurls.append, and we're gonna append the href, but we only want to do that if href not already in visited URLs. So if href not there, not in self.visited URLs, otherwise we're just going to return and say already done, skipping. Okay, so now it shouldn't process the same page twice. Let's give it another run. And there it goes. Now it does look like it's repeating some of the same pages. Oh wait, now we're saying processing before it happens, so let's do this. Let's say, let's not print out the processing message until after we determine that it's one worth checking. That way we don't get a bunch of garbage text. So let's start it again. And now we can see that it is in fact looking up unique pages now. And it doesn't look like it's doing repeats. So it's actually crawling. So let's stop it. Now what I want it to do is say after it's done processing, I need to know when they're all done. How do I know when it's like all completely done? So we'll say maybe we'll store how many levels deep it is, or how many pages are left. So yeah, we'll say self.active processors equals 0. And then every time we do this, we'll say active processors plus equal 1. I'm not convinced this is the best way to do it, but I think this will work for now. This way I can figure out when they're all done. And so we'll also say after it returns, right before it returns, and right before it returns there too. Now wait, if it's not threaded, I guess it really doesn't matter. So it's actually in the start, so it's after start is when we're going to say basically complete. That's all we really need to do here. And then if we were going to do it in a thread pool, we can basically just say like with thread pool executor, and we'll do this in a second. We'll multi-thread it in a minute. With thread pool executor, and then do basically process page. Yeah, basically the same thing. Okay. I think that's okay. Oh, I don't need this anymore. I can delete that. So I don't think my blog has that many pages, so it shouldn't take too long to crawl through every single page. But at the end, okay, connection timeout. Oh, that's kind of a broken looking URL. Okay, so maybe I need to have a try on the get. So if it fails, we can just gracefully return, because it looks like the whole program crashed on that exception. So if it fails to do a get, like it times out, max retries exceeded or whatever, that's fine. We will just return and not care. Okay, so it's gonna run again. Let's see if it gets all the way through. And actually, the whole time we're doing this, it should be storing the statistics. It should be storing all the data in there. So we'll say self.data is just a dictionary. And then every time we visit a site, we can store all that information we talked about storing: the title, the URL, the parameters. Or since it's all sequential right now and it's not threaded, we can actually just do the CSV row right after we get the response. Right about here. Here's where we could say CSV write title, HTTP response code. What else? The full URL. We'll have a special column, say contains query params. That way we can filter very easily in the spreadsheet and put those with the query parameters way up top as like high priority to look into. And any scripts found? Yeah, we'll just say, how about the number of script tags found? That way the ones that have high number of script tags we can kind of take a look at, see if there's any insecure JavaScript being added. Okay. So we'll also say self.csv file equals. Now I've got some examples around here. CSV write. Yeah, there we go. We'll just copy that line. And so it's going to be csv.writer open And we should take, we'll say the output file name. Output file name is going to be the CSV file, and we will default that to output.csv. Okay, now we got to import CSV like that. Okay, then whenever we want to add a row, we can call, self.csv file .write, and then we pass it a list of all the things. And actually, we should probably pass it a header line .write, and so what it's going to be title href. Oh, it's still crawling down here. Is it looping then? It's starting to look like, yeah, because of the fragments it might. I don't have that many pages, so I feel like it is looping. Yeah, see, well, yeah, it looks like it's got some kind of loop problem, so we'll look into that in a minute, but that's okay. We can set a max pages on it too, so let's do that actually. Right after we fill out this href contains query params, and then number of script tags. Okay, so there's 4 fields, and we're gonna write down each one of them here, and that's going to be soup.title string, the href that we're getting, and then contains query parameters, and I guess that's just going to be a boolean. Let's see, can we do just like cast URL dot, no, it's params, I think, params, URL parsing params, yeah. So params is the get query, and then number of scripts, I'll leave that one off for now. Actually, you know what, I'm just gonna leave off I'm just gonna store the title in the href for right now. I think that's good enough. We'll basically be getting an outline of the site and see all the pages. So we also want max pages, and we'll just default that right now at 25. Self.maxPages equals max pages, and self.processedPages equals 0. And so everyone we start processing, even if it fails to get processed pages plus equals 1. And then we'll just say if self.processedPages is greater than equal to self.maxPages, then just return and don't do any more. Okay, so let's try this. And since we gave it defaults, it should just use a default output file and default to our 25. It has no write. I think it's called write row. Write row. And down here, same thing, write row. A bytes-like object is required, not string. Do I need to encode each one? Mythic says, I'll see ya. So it sounds like you're taking off. Have a good one, man. I'm glad you came out and hung out tonight. A bytes-like object is required, not a string. Well, I thought that's what encode will do. So... why is it not happy about that? Let me pull open my CSV example. Right row, you pass it a list of strings. Right? Title and href. That shouldn't be a problem. A bytes-like object is required, not string, but maybe if I just prefix it with the B? No, it's not going to give me away that easy. Now, brain fart. Yeah, I did do encode. Decode? I don't need decode, I need encode. But why did it still not like it? Okay, so if I run it again, it still says the same thing. It's complaining about... what if I just gave it numbers? A bytes-like object is required, not string. Hold on a second. No, that looks good. CSV file equals CSV writer. And then right row. That's weird. I am a little surprised that it's behaving that way. And so I'll try one last time just for good measure, but it's... oh, am I missing? No. No, no. That all looks good. Let me just try it without that. So then it complains about the same thing. What is going on? I am... let's see. So it should stop. Okay, it stopped after 25. That's good. So... why is it having such a deal here? Maybe it's because print error loading CSV file. Maybe it's erroring on the open and then it has no handle to actually work with. No? Okay. Having a brain fart here. It looks fine to me. We got a list of our stuff. Let's try an empty list. Okay, let me try Googling specifically CSV writer Python. Because this is a little... oh... it's because it's selected as open binary. Okay. Yeah, that was all it is. That was my brain fart right there. It had WB, so it was open for write binary. And so it wanted binary data, but I'm really just writing text data. Okay, so where did it put? Let me go into... Okay. Sorry, I had to cough and take a drink of water. So it output the CSV, but oh yeah, then I deleted all the rights, so now I got to put them back in title and href, and then down here, I guess I deleted the whole thing. So it's self.csv file dot write row, and then we pass it the it was a title in the href, so it's going to be soup.title.string, and the href, so just like that. So now if we run it, we should get a good CSV file. Okay, now if we open it again, now we can see that we did in fact get the titles and all the hrefs here. And if we wanted to add anything else, we could obviously add them here. So excellent. We've got a nice little crawler that'll stay within a domain and crawl within a domain. So I'm actually going to, let's see, let's check the addenda. So crawling a domain, what I didn't do in there was the with a thread pool part. So let me pull open, I think I have some threading examples. We just did them the other day. Where did we do it? We did it in the port scanner. Let me pull up the port scanner example. Port scanner example is called port scan collection. Yeah, there we go. So in the Python port scanner, we had a thread pool. Yeah, here it is. So that's the chunk of code that I want, and I think we want to put it. I think we want to put it right here, basically, and tell it to go. You know what? I don't think that is, because it's recalling itself recursively on itself. So inside the one thread where we're about to call the other one is where we should say kick off a new thread. Yeah, I don't think the thread executor is actually going to be the way to do it. Just because of the fact that it's a recursive algorithm or function. Brendan Garcia says hi. Hello, welcome. Welcome aboard, welcome back. So I'm gonna hold off on making this multi-threaded right now, but I think the approach I would take for this one would be, just like I'm keeping track of the processed pages, what I would do is keep track of the active threads, and then in the process, right before I call another process page, I would say if it's full, if the number of active threads has already been reached, then wait until the active threads is not too high, and then go ahead and process. And then I'd have like a max number of threads, self.max threads. So I think that's how I would do it. But let's see, I'm gonna move this one over to done for now, and let's say okay, so what else do we have left? I'll talk about Scrapey. Let's see, I think I'm gonna skip doing the proxying requests. Now I will give you a tool that I would recommend if you really just want to have a tool to do it. I'll probably save this for another night. And Burp Suite has all kinds of tools in there, and it's got a proxy in there for you. You can also use the Zap proxy, the OWASP Zend attack proxy, Zap. That's one you can use. There's Fiddler. Oops. There's Fiddler. Fiddler's a good one. That one will let you also do the SSL decryption. So I'm gonna cross that one off. And we're at the 2-hour mark now, so I'm actually not gonna do the GUI rest tester in PyQt5, but I will mention that I did do that in Java, and so this was essentially what I wanted to recreate, and I did it in Java, and it's basically you give it a URL, you can choose the drop down and choose whether you want get, post, whatever, set any custom headers, set any custom value, and then you can hit request. And so it's just a simple GUI for doing requests. So maybe another night I'll do that. I want to explore PyQt5 more. And Scrapey, I do want to mention Scrapey. If you don't want to build your own crawler, well, I guess you will still sort of build your own crawler, but within a framework that they provide. So they provide classes like Scrapey.spider, and you can tell it starting URL names, and it's kind of like what we just did. But it's got a much more powerful scraping framework where you can start the jobs, pause the jobs, and just keep track of them. So, sorry we didn't get to some of the other ones, but I think we did good for building a cookbook for doing some basic Python scraping and crawling. We looked at beautifulsoup and how to crawl a domain with it. So I hope you guys enjoyed it, and if you have any suggestions for other things to do, or if you were disappointed we didn't get to some of those other points, please let me know, and have a good night. Thanks.